Hello, in this video I'm going to discuss the CAE AS level paper 1-2 of 2023 June. Question number 21. A longitudinal wave is traveling from left to right. The graph shows the variation of the displacement of the particles with distance along the wave at one instant in time. Displacement to the right are positive, displacements to the left are negative, which labeled point represent a compression. So here you could see, you already may know that the compression or rarefaction is happening when the displacement is 0. The point will be the center of the compression. If this point is the center of the compression, the other particles will come closer to that point, creating a compression region. If this is a rarefaction point, the center, the particles on either side of it will be moving away from this point. So the center will be having a displacement of 0. So out of these 4 options, you may conclude that it will be either B or D. So here you could we can analyze these 2 points. Here it is given that the displacement to the right as positive, displacement to the left as negative. Here it is positive, here it is negative. So the particle on this side is moving to the right, the particles of this side is moving to the left. So the particles are coming closer to a point, which means that this creating compression. At point D, the left side of this point, the particles is moving to the left, and the right side of this point D, the particles are moving to the right, creating a rarefaction. So this point B is compression, point D is having rarefaction. So the correct answer would be option B. Question number 22. A source X emits a sound wave of constant frequency f. The wave is subsequently received at a stationary detector y. The frequency of the wave that is detected by y is less than f. What could be the reason for this? So out of these options, the first A and B options, between X and Y, the wave undergoes diffraction and it is undergoing a reflection. Both will be wrong, because here from this question we can conclude that it is a question based on the Doppler effect, right? So I hope you guys remember what is a Doppler effect. In this case, this is the source which is emitting a constant frequency, okay? And here is a front observer, and on the other side is the back observer. The source is moving to the right, okay? Left to right. So you may find out as it is approaching the this observer, stationary observer, the frequency is more, and when it is frequency is more, right? When it is leaving, the frequency is less, which means that the observer receives the frequency what is less than f, meaning the object which is emitting the sound waves is moving away from y. So the correct option will be option C. Question number 23. A beam of visible light is in vacuum. What could be the frequency of the light? So you need to find out the frequency. So you need to use the formula V is equal to F lambda, the wave equation. Here it is a visible light which is a part of electromagnetic spectrum. So you know the velocity would be 3 times 10 to the power 8 meter per second. And you need to know the lambda, right? You can rearrange this formula like this: V divided by lambda, and to our knowledge we know the visible region is lies on these wavelength. So the first wavelength you could consider lambda is equal to 400 nanometer. It will be in the nanometer range. 400 times 10 to the power minus 9 meters, okay? So f value could be in 3 times 10 to the power 8 divided by 400 times 10 to the power minus 9. So the frequency value would be 7.5 times 10 to the power 14 hertz. So from this you could conclude that the frequency range is in the terms of 10 to the power 14. Out of these options, option D is really close to that. Here you could find out there's a difference in the values, like this is 5 given, but here it is 7.5 that we calculated. You can verify the value by using the other end of this wavelength region, like lambda 2 you could take as 800 nanometer and find out the frequency. So the frequency will be ranging from 7.5 10 to the power 14 to another value, and we are gonna find out that value. So please do the calculation and find out the region. This would be 3.75 times 10 to the power 14 hertz, which means that the frequency is ranging from 3.75 to 7.5. So this value is clearly gives the frequency of this visible light. So option D. Question number 24. A vertically polarized beam of light of intensity I0 is incident normally on a polarizing filter. The transmission axis of the filter is at 45 degrees to the vertical. The beam of light transmitted by this filter is then incident normally on a second filter. The transmission axis of the second filter is horizontal. What is the intensity of the beam of light after transmission through second filter? You need to find out the intensity after passing through the second filter, right? First of all, we can find out the intensity after the transmission through the first filter and then to the second filter. Okay, so which formula you need to use? The Malus formula. Here in this formula, just be careful, the theta value that you are taking is the angle between the transmission axis and the plane of polarization. Here it is vertically polarized, so this is the vertical axis and this is the transmission line. So it is directly given, the theta value. So please substitute I is equal to I0 cos square 45, and you will be getting this value for cos square 45 degree is 1 divided by 2 or 0.5, which means that I0 by 2. So when this intensity is passing through the first filter, the intensity would be half of this initial value. Okay, then you can do the same for the second filter. So here the first filter was on 45 degree, right? So the light wave which is coming after passing through the first filter will be having a polarization in this direction, right? So this is the polarizing plane and this is the filter transmission axis. So this angle is what you need to take, and you know that here it is 45 degree, so this this value also be 45 degree, right? In the second filter case also, you could find out the intensity by using this formula and just find out what is the incident intensity. Incident intensity is half of the initial value, and cos square the angle between the transmission axis and the polarization, which is 45. So I0 divided by 2 multiplied by 1 by 2, which means that I0 divided by 4. So the intensity after transmission after the transmission through the second filter would be 1 by 4th of this initial intensity, which means that option B is the correct answer. Question number 25. A stationary wave is formed by two progressive waves traveling in opposite directions along the same line of travel. Which statement about the two progressive waves is not correct? As you know, the stationary waves are forming by the superposition, but here the first option, they must have a constant phase difference, is not required. Okay, this is not required, but they must be having the same frequency and same wavelength and hence the same speed. So option A is the correct answer. Question number 26. The sound from a loudspeaker placed above a tube causes a resonance of the air in the tube. A stationary wave is formed with two nodes and two antinodes as shown. The tube has height 60 cm. The speed of sound in air is 340 meter per second. What is the frequency of the sound? You need to find out the frequency. So in this case, the velocity is given 340 meter per second, and you know how to find out the frequency using the wave equation, that F is equal to V divided by lambda. But we don't have the lambda value, but you could find out using this length. Since this is a complete lambda, you may divide this whole lambda length into 4 parts. Okay, so this length would be lambda by 4, which means that this length is lambda by 4, and from this point to this length is another lambda by 4, and the length from this to this is also lambda by 4, which means that in this whole length L there is 3 lambda by 4 wave, right? So L is equal to 3 lambda by 4 is the equation that we can apply on this condition. So lambda would be equal to 4L divided by 3. So please substitute for L as 60 times 10 to the power minus 2. You need to convert this centimeter into meter and do the calculation. You will be getting lambda is equal to 0.8 meter. Okay, now you can substitute in the formula, like 340 divided by 0.8, which is equal to 425 hertz. Which option is close to this value? The option A. So for the question number 26, option A is the answer. Question number 27. A continuous progressive water wave in a ripple tank passes through a gap in a barrier and diffracts. The width of the gap is greater than the wavelength of the wave. Which change causes the wave to spread over a large angle as it passes through the gap? So here, out of these options, you could find out the value by easily the understanding of this diffraction. So here, this gap size is greater than the wavelength, right? So in this case, majority of this wave is not diffracted. The diffraction is only for these end of this wave, right? But if this wavelength and the gap size both are almost the same size, then it will diffract at larger angle. So what we need to do is to make these two values the same. If this gap size is really more, the diffraction amount will be really less. So a small decrease in the wavelength of the wave, will it be making the diffraction more? No, these lambda is now it's less than the gap size, right? So this won't be increasing the amount of diffraction. Then option B, a small decrease in the width of the gap. Yes, if you are decreasing this width, it may be equal to the lambda value, right? So this is one of the correct option. A small increase in the frequency of the wave. So if you are increasing the frequency, what will happen for the wavelength? Wavelength would be decreasing, right? So as the wavelength decreasing, it won't be making these two values the same. The gap size is really large now, so this is not possible. And option D is a small increase in the height of the barrier. That's also not gonna increase the amount of diffraction. So the correct option is option B for this 27 question. Question number 28. The diagram shows a view from above a double slit interference demonstration. L is a monochromatic light source with a vertical filament. B is a barrier with two narrow vertical slits, and S is a screen upon which interference fringes form. The intensity is I at the point on the screen where the center of the fringe pattern forms. When one of the slits is covered, what is the intensity of the same point on the screen? Let's consider the case of double interference. So here is a source placed. When this waves from the source is reaching this double slit, where the slits will be forming as a new source for this waves, right? So from this slit there will be a wave generated, or waves passing and reaches this point that we can consider. Okay, the same amplitude wavelength will be forming, waves will be forming from the second slit too, okay, reaching on the same point. Let's consider the condition. So there will be superposition at this point, right? So at this point we have like a two amplitude superposition. So here it will be 2A that is incidenting at this point. So how the amplitude and the intensity is related? The intensity will be proportional to the square of the amplitude. So in this case you are having 2A amplitude, which means that the amplitude is 4 times the amplitude square. Okay, now let's consider one of the slit is covered. So if the slit is covered at this point, the amplitude of the wave would be only A, since only one wave is incidenting at this point, right? So the intensity would be proportional to A square only. Okay, so here previously it was 4A square, now it is only A square. So from this you may find out that the amplitude square is proportional to I by 4. So here the intensity that we are having after the covering of one of the slit is just 1 by 4 of this initial value. So which one is the correct option? Option D. Question number 29. Green light of wavelength 550 nanometer is incident normally on a diffraction grating and produces a diffraction pattern on a screen placed 3.5 meter from the diffraction grating. The third order maximum on the screen is at a distance of 0.75 meter from the zeroth order central maximum. What is the distance between two adjacent slits in the diffraction grating? So the formula that you know about on this diffraction grating is n lambda is equal to d sine theta. Here n is the order of the fringe. Here it is given, it is the third order, so n is equal to 3. Lambda value is given as 550 nanometer, and the d value stands for the slit distance, okay, or the slit spacing. This is what you need to find out, but we don't have the theta value, right? So to find out the theta value, just consider this triangle. As you could find out, this is a right angle triangle, and this is the angle theta that we need to find out, right? The angle theta is the angle between the central maximum to the order of fringes that we are considering. So this is the third order maximum, right? So this would be the angle. To find out this angle, just find out tan theta value. Tan theta is 0.75 divided by 3.5. So theta value would be tan inverse of 0.75 divided by 3.5. So you'll be getting the theta as 12.08. So now you could substitute in this formula. Before that, you need to rearrange that d is equal to n lambda divided by sine theta. That is 3 times 550 times 10 to the power minus 9, because you need to convert into meters, divided by sine of 12.08. That is equal to 7.88 times 10 to the power minus 6 meter. So which one is the correct option? 7.7 is there, 7.8 is there. Since it is 7.88, you could find this option C is the answer. Question number 30. Which charge can be carried by a charge carrier? You know that any charge observed in nature is a whole number multiple of an elementary charge. The elementary charge is usually the charge of an electron, that E. Okay, Q is the charge. So it will be an integer multiplied by the charge of an electron. So If you're dividing the charge by this elementary charge, you'll be getting an integer or a whole number. Okay, so you can check for each options and find out which one is giving you the whole number. Let's check for the first option, 1.1 divided by 1.6, because the E value is 1.6 times 10 to the power minus 19 coulomb. So you will be getting 0.68 value, which is not a whole number, so this is not the correct option. Option B is 4, that is, so to find out 4 divided by 1.6 is 2.5. That's also again a fraction. Option C is 4.8. If you're dividing it with 1.6, you will be getting 3, which means that option C is the correct answer. You can check for this option D also, that is 9.1 divided by 1.6, which will give you 5.68. So out of these options, option C is the only one which is giving you a whole number. So option C is the answer. Question number 31. A resistor of resistance R is connected across a cell of electromotive force EMF E and negligible internal resistance, which a single change to the circuit would lead to the largest increase in the power dissipated in the resistor. Okay, so here you have a cell with an EMF value and a resistor, right? So the whole E value, this EMF is passing through this resistor. Okay, so the power equation is V square over R. We actually have like 3 forms of this equation, that is V is equal to I times V and P is equal to I square R. So these 3 equations that we could use, but here I am using this first one to explain it. Okay, so the first option is option A, doubling the value of E. So if you are doubling this E value, that is P is equal to E square by R, since the internal resistance is negligible, you can choose this one. Okay, so if you are doubling this, you will be getting 2E square divided by R, which means that 4E square by R. So it is increasing, 4 times increases the power dissipated, right? So option A is the correct answer for this. You can check if you want for the option B also, doubling the value of R. So if you are doubling this, it is making half of this initial value, and halving the value of E. If you are halving this value also, it's decreasing. Halving the value of R, it's again it's not it will be giving like halving this resistance, right? So it will be only 2 times the initial value. So which one is giving you the largest one? 4 times the initial value, right? So option A is the answer. Question number 32. An electrical cable is made up of one thick strand of copper wire that is surrounded by 8 thin strands of copper wire. All 9 strands of wire are connected in parallel with each other. A section of the cable is shown. Each thin strand of wire has cross-sectional area A and length L. The thick strand of wire has cross-sectional area 4A and length L. The cable has a total resistance R, which expression gives the resistivity of copper. Since these two are of the same material, the resistivity stays the same, right? In this question, the point to be noted is that the 9 strands are connected in parallel, right? So the resistance value is having a formula, right, like rho L by A, right? For the thin wire, you may find out the value as rho L by A, and for the thick wire, it is rho L by 4A, since the area of cross section is 4A, right? So the total resistance, since it is connected in parallel, 1 by R would be equal to 1 by of the resistance of the thin wire, but you need to multiply it by 8 because we have like 8 thin strands, right? Plus there is 1 divided by the resistance of the thick wire. Okay, so 1 over R is equal to 8 times 1 divided by the reciprocal, right? 1 divided by the thin resistance of the thin wire is rho L divided by A plus 4A divided by rho L. So in this case, you can take the factor rho A divided by rho L as common. So you'll be getting 8 plus 4, which is 12A divided by rho L. From this formula, 1 by R is equal to 12A by rho L, we can rearrange, right, to find out the resistivity. So resistivity is equal to, just take this one to the other side. So you'll be having the formula 12A, this R is taken to the other side, AR divided by L. So which one is the correct answer? Option D. Question number 33. A car has sensors for detecting the light intensity and temperature of its environment. The sensors make use of a light-dependent resistor (LDR) and a thermistor. The car moves from a warm, dark environment into a cold and bright environment. What are the changes to the resistance of the LDR and the thermistor, right? So the resistance of this LDR is varying with the light intensity. Okay, so this graph would be great to remember how the resistance is varying for an LDR. Okay, so this is for LDR. So the intensity is low here and intensity is more here, which means that here it is the dark region condition and here it is the bright region condition. Okay, so the resistance would be like this, inversely proportional. So in the dark condition, the resistance is more, on the bright condition the resistance is less, which means that on this question, according to this question, it is moving to the bright environment, right? So the resistance is decreasing, so it will be either C or D. Then let's check for the thermistor also. For the thermistor, it will be having the same similar graph, but instead of this intensity, we will be having the temperature, which means that the temperature is low, or you could say the cold region. On the other side, it is warm region. Okay, so the graph would be the same. On the cold condition, the resistance is more. On the warm condition, the resistance is less. So it is moving from warm to cold, which means that on this cold condition, the resistance is more. So the resistance of the thermistor is increases. So option C is the answer. Question number 34. A student assembles the circuit shown. Okay, so you have like diodes and lamp. Which row describes the state of the two lamps? So here, since these are connected in parallel, the voltage that you applied will be passing, distributed like equally, right? So this region will be having the same voltage, and this region also will be having the same voltage. Okay, so when the switch is on, or the electricity is passing, it is passing this, the current is passing from this positive terminal to the negative terminal, right, in this direction. So the diode is having a property that if it is forward biased, it will conduct. It will if it is reverse biased, it won't be conducting, which means that if it is connected in this way, okay, so this is the positive terminal and negative, and this is the positive and negative for a diode. Okay, the positive of this battery is connected to the positive of this diode, then it will conduct the electricity. Okay, but if it is reversely connected, okay, in this condition, the positive is connected to the negative of this diode. In this case, it will not be conducting. Okay, so for this this diode, the positive and the positive are directly connected, which means that it will conduct. So the current will be passing through this. So lamp 1 will be on. Okay, so for the lamp 2, if you could check these two diodes, you could find out the one of the diode is forward biased, because the positive and positive is connected, right? So the current will be passing through this one, this line. So the lamp 2 will be having the it will be like turned on. This path won't be conducting the electricity. Okay, so both the lamps will be on. So option D is the answer. Question number 35. Kirchhoff's first law is a consequence of the conservation of which quantity? In this Kirchhoff first law, we are describing about the current conservation, right? So, or the charge conservation, because if it is reaching any junction in a circuit, okay, let's consider the case there is a junction, okay, so this is a junction and the current is passing I, okay, I is the current passing. So let's take I1. When it is meeting the junction, it will be splitting into two, I2 and I3. That summation of I2 and I3 will be equal to I1, because the charge is which is contributing to the electricity, right? So the charges anyways would be the same. It is not gonna disappear when it is meeting the junction. It is just splitting into two path, right? So the conservation of charge is used for this formulation of Kirchhoff first law. So the option A. Question number 36. Three identical cells, each having electromotive force EMF E and negligible internal resistance. The cells are connected to three identical resistors, each of resistance R, as shown. What is the potential difference across one of the resistors? Here you may find out there is some changes in the EMF connection, the cells connection, okay. Let's just figure out how the cells are connected. This cell is like this, the second one is connected like this, the third one is connected like this. And you could find out the total EMF of this whole connection, since these are in a series connection, okay. This is E, these second one will be added, but the third one will be will be less than the total, which means that the total, the whole combination will give you an EMF of E. The potential difference will be E only. The total EMF passing in this whole circuit will be E only in this case, right? And it is passing through the identical resistors, right? So you could find out the total resistance of the series circuit. The three resistors are connected, right? So it will be added R plus R plus R, which means that 3R is the total resistance in the circuit. So you know the voltage value or the EMF value and the resistance value. From the Ohm's law, I is equal to V divided by R, right? So here the EMF value is E and the resistance, the total resistance value is 3R. So this is the total current passing through it. So the same current will be passing through the identical resistors, right? So the current which is passing is E divided by 3R. What you need to find out the potential difference across one of the resistance. So use the same Ohm's law. V is equal to IR. Here the I value is E divided by 3R, and you are considering only one of the resistors, that is multiplied by R. R and R get cancelled, so it will be E divided by 3, which means that option D. Question number 37. In the potentiometer circuit shown, the reading on the ammeter is 0. The light dependent resistor LDR is then covered, and the ammeter gives a non-zero reading. Which change could return the ammeter reading to 0? So in this potentiometer circuit, this whole power supply, let's consider as V, is the same as the voltage across this one, right? Along this one also, the potential difference would be the same. Okay, so here let's split. Here is a fixer resistor, so the voltage across the fixer resistor and just add with the voltage across the LDR. These two would be equal to the total voltage V, right? So when it is connected to this slide, the particular length of this metal wire is having the voltage VR. it is completely fallen on this length. Okay, the resistance is proportional to the length, which means that on this length, as you are changing the length, the potential difference also be changes at a particular point. Okay, let's consider a particular L1 value. On this L1 length, the voltage and the voltage across this L1 length both will be the same, as the length and the voltage are like proportional. V is equal to IR. As the resistance changes, the voltmeter is also changes proportionally, right? The same for the voltage across the LDR. It is proportional to the length on this region L2. Okay. So here what we need to do is we need to find out the ammeter reading is 0. When the ammeter reading would be 0, when these two potentials are the same, okay, or these two lengths are having the same resistance value. Okay, similar the resistance of this LDR or the fixed resistance. Okay, so here the LDR is covered. So as the LDR is covered, the intensity ranging on the LDR is less, decreases, which means that the resistance value is more, right? So here now it's having a high resistance in this region, which means that it will be needing a longer length. If this is having a higher resistance, most of the voltage will be dropping at this region only, on this region only, right? So the length also must be more. So this length must be increased. So let's check all these options. First one, the option A, decreasing the supply voltage. It won't be changing the ammeter reading. Increasing the supply voltage. No, it won't be changing. Option C, moving the sliding contact to the left. Yes, if it is moving to the left, the length will increase, which will increase the resistance, which will increase the potential drop, right? Which will make the ammeter reading a 0 value. So option C is the correct answer. Question number 38. What are isotopes? Isotopes are the elements which are having the different number of neutrons. So the nuclei of the same element with different number of neutrons. So option C. Question number 39. A neutron is fired at a uranium nucleus. The neutron is absorbed by the nucleus, which then splits to form a nuclei of barium and krypton. What is the number of free neutrons emitted when the uranium nucleus split? So in this condition, this uranium 92 235 is absorbing one neutron, right? Which gives you the barium 141, 56 and 92, 36 krypton and a particular number of neutrons as well. You need to find out this value, X value. Okay, so in this case, in a nuclide equation, both the proton number and the neutron number will be conserved, like the mass number would be conserved. You don't have to check for this proton number because here it is 0, the proton number for a neutron, right? The charge of a neutron is 0, so you don't have to consider this proton number and waste your time. Just check for the mass number. Here on the left hand side, it is 235 plus 1, which means that 236 on the left hand side, that must be equal to the right hand side, right? Which is 141 plus 92 plus this X value. So 141 plus 92 is 233 plus X. X is equal to 236 minus 233, which is 3. Okay, so this value would be 3. So 3 neutrons is emitted. So option D is the answer. Question number 40. A pipeless meson has a charge of plus E, where E is the elementary charge. It consists of an up quark and one other quark. What could be the other quark in the pipeless meson? In the case of meson, the quarks, it is made up of quarks, right? A combination of quarks. Mesons is consisting of one quark and one anti-quark. Okay, when one quark and one anti-quark is combining, it is forming a meson. In the case of bosons, it will be 3 quarks only. Okay, so here out of these options you can neglect the option C and D, as these are not anti-clock. It would be either anti-down or anti-up. So just consider the charge distribution. So here it is pi plus, which is having a charge of plus E, and one of the quark is up quark, which is having a charge of plus 2 by 3e plus an element, right? An element, just take it as x. Okay, so just rearrange this one to find out the x, which is plus e minus 2 by 3e, right? E, just take it as common, so 1 minus 2 by 3, which will give you like 1 divided by 3. So the charge of this anti-quark is 1 by 3e plus 1 by 3e. Which of these anti-quarks is having plus 1 by 3e charges? Anti-down and anti-strange. Which options is correct? Option A, because anti-strange is not given, only anti-down is given. So option A is the answer. So by this we finished the solving session of this paper 1-2 for this May-June 2023. I hope you guys understood all these solving methods. So thank you.